Okay, to try and provide a easier to use and more expandable library for open source GIS software for Python, we created SpPy, Spatial Python Package. And the real goal here was to make it easy to use for doing a bunch of different types of programs, batch processing, GUI, web services, expandable for a wide variety. This is really what started us doing this, because GeoPandas is hard to expand. High performance, the open source software is very fast, you'll find. So that's not much of a problem. And then high reliability is up to us and the other open source developers to make sure we test and design our stuff well. SpatialPy does rely upon a number of different libraries, so you'll need to install all these libraries. It also runs best with Python 3x. It's available on GitHub. If you just click here and go to GitHub, the largest repository for software, and then click on clone or download, and I recommend downloading the zip file. And then you can bring the zip file into a folder like I did here, and inside of it you'll find a couple of folders, especially examples and SpPy. Those are really the two main folders, and I've got those here. And if you go to SpPy, you'll see there's a series of libraries, and I'll talk a little bit about those. And then there's some examples, including some data that we'll be using, some tests. These are tests that we use as we develop it to make sure everything's working properly. And I've got a couple files here that I've been working with, but I'm going to start off new and go to the website. I should say back to the website. And the first thing we want to do is we'll want to import the Spatial Python libraries into a script. And here you can say what I've done is I've taken and I've appended my system path to include the SpatialPy path. I have imported from Shapely some geometries. Shapely, this library that includes the ability to work with geometries like point, line string, polygon, multi-polygon. And then imported a bunch of the SpatialPy libraries as well. And then I'm going to set up some folders and some paths to those folders, just so that I have them easily available. This is my temp folder path, and actually I'm going to modify that and do it as outputs // so I've got an output folder that I've got here. That'll make it easy for me to delete things as I develop. And then we've got the country layer from Natural Earth and a simple raster file. I think that's LiDAR from Napa County. Okay, so first I'm going to copy and paste this piece of code. And this shows us working with vector data. So if I go ahead and do a breakpoint, hit run. Whoop. You'll see the first thing we do is create a vector data set. So this is going to create an object in memory. It's part of the SPVectors library. I'm going to create an SPVector data set. Then we're going to go ahead and load from our country's shapefile. Now we've got it loaded in memory, and we can do a bunch of things to find information about it, like the type. So it's a polygon shapefile. We can get its coordinate reference system or spatial reference system. This is encoded with EPSG 4326. I just happen to know that's WGS84 geographic. We can get the number of features, 177 countries. We can find the bounds. Of course, it's almost the entire planet. And then we can also get the number of attributes and print that out, 94 attributes. And these are the actual columns, and then we can print out information on each of the columns for attributes. Also, if we want to, we can then go ahead and just save the data set to a new shapefile, and it will save a copy of that data set. So that's one of the ways you can make a clone or a copy of a data set. Going back to the website and going down, there's a bunch of we call OneLine Operations to do operations on spatial data. So these are things like buffer, where you just supply it with one spatial data set. Now, one of the things about SpPy is you can provide it with a file path to a shapefile, or you can provide it with a vector data set in RAM, or you can provide it with just one geometry, any of those three. And internally, SpPy will take care of that. Here, I'm taking our country shapefile and then buffering it out by 10, which is quite a bit. But I'll just go ahead and run this. And I have QGIS open and ready for us to take a look at the result. Oh, and it's done. So as you can see, it's very quick. And now we can go ahead and take a look at our buffered countries, the centroids of our countries, convex hull of our countries, and a simplified version of our countries. So obviously I'm kind of playing around here, not a real application, but you can see that everything works great. You can do pretty much anything you want to with the attributes. So I happen to know that there's a label rank attribute inside one of the files. So I can go ahead and get an attribute value. So this would be from the column label rank. And it would be the first row, that would be the 0 row. And there's the actual value from that attribute table. I can also set an attribute value, so I can change it. I can delete an entire column of attributes, and I can add columns of attributes. And then, of course, then I can save that right back out again to a new shapefile. And another one we can do is selections and subsetting. So here I'm going to go ahead and create a new layer, a new data set, and then I'm going to load from the countries file. I'm going to select scale ranks that are greater than 2, or here greater than or equal to 2, or here less than 2, here less than or equal to 2. So different ways of selecting, and that will return back a selection object that simply includes the feature indexes for those features that were selected. The final one I'm going to do is actually select where admin is the United States of America. So selecting out the feature that's the United States of America. Then I'm going to pass that to a subset by selection function and save that out as my selection. And then if we go into QGIS, you'll see that I've selected the United States of America out of the countries file. Just kind of while we're adding and removing features, you can also delete features from a shapefile. Here I just delete whatever the first feature of the shapefile is. I'm not going to go over that. It's pretty straightforward, I think. What I will do is talk a fair bit about this geometry, data sets, and shapefiles issue. So what we can do with SpPy is we can create a geometry. So here what I've done is set up top, bottom, left, right as the bounds of a rectangle. And then I've created a polygon where I'm going from the top left to the top right, to the bottom right, and to the bottom left, and then back up to the top left. And you need to do this. You need to come back around to the first point again. That's part of the OpenGIS standard for geometries, which is what Shapely is implementing. And that's going to give us a geometry that's a big box, big rectangular box. You can do other geometries, whatever you want. It's pretty easy to do. And then we can go ahead and create a new data set and add that big box feature to that data set. Now when we save that, we're going to have a shapefile with a big box in it, which is not that exciting, but it will be in a minute. So there's our big box, and there it is. Okay, and now I'm going to go ahead and do some overlay operations with geometries. So we've got our big box that we defined up above, and I'm going to go ahead and intersect that with our countries, our United States, America shape, And so that's going to be the intersection of those two. So anywhere where the two of them overlap. Then I'm going to perform a union of the two, so combining the area of both of them. And then we'll do a difference. We're going to subtract the area of the big box from our selected one. And if we go back into QGIS, we will see there's our difference where we've subtracted it. There's our intersection where the two of them overlap. And what was the file name for the union? Union. I like that name. And there's the union of the two. So easy, fast vector operations. Now, we did this with a big box that was a geometry, but we could also do it with a data set. Same operations, you can just pass it a data set that's in RAM, or we could pass it the shapefile path that we saved the big box to. So any of those work with pretty much any of the function calls. And I'll continue.